Today's lesson 3-5, we're going to be talking about multiplication strategies, mainly cross-canceling strategies. What we're going to be doing is simplifying our fractions before we multiply them to save us the trouble of having to do it afterwards. The benefit of that is that if you simplify before, you're dealing with much easier numbers than if you wait until you've multiplied them. So I'm going to model the first 4 problems here, since we've been discussing these types of strategies for a while now, and I'm going to let you do the rest of those on your own. So starting with number 1, we have 2/3 times 30, and the first thing we need to do is change that 30 into a fraction. We can do that by simply putting a 1 underneath it. And then we're going to use our cross-canceling strategy, which means that we're going to try to simplify diagonally instead of vertically. So in the first one, we're going to take a look at our numbers that are across from each other or diagonal from each other. We're looking at 3 and 30. And we're using the same skills that we use in simplifying our answers when we add fractions or multiply fractions. We're looking for a divisor, a number that will go into both 3 and 30. And you should use the same tricks that I've taught in the past, where you're basically looking at your smallest possible divisor, which is your smallest of the two numbers. In this case, it's 3. So I'm going to look at 3 and see if I can use that to divide into both 3 and 30. And it turns out that I can. So I'm going to use 3 and divide 3 by 3, and that's going to cancel out this 3. 3 divided by 3 is 1. I'm going to replace the original number there with the number 1. And I'm going to cross out my 30 and divide by 3 as well. I must use the same divisor, just like when we're simplifying fractions. And 30 divided by 3 equals 10, so I'm crossing that out and I'm replacing that with a 10. And it's following the same protocol as we've used in the past, where if you're going to do something to one number, you must do the same to the other. And now we can take a look at our other two numbers that are diagonal, the 2 and the 1, and we realize that the 1 is as simple as it can get, so there's nothing I can divide both of these numbers by that would make them any smaller. So now I can just multiply 2 times 10, which is 20, and 1 times 1, which is 1, and that gets me 20 over 1, which is equal to 20. On the second problem, again, we have a whole number, and we're going to, again, turn that whole number into a fraction by just putting a 1 underneath it. And then I'm going to look again at my numbers that are diagonal each other, 5 and 35. And I know that 5 goes into any number that ends in a 5 or a 0. So it will go into 35. So I can begin by dividing by 5. 5 goes into 5 one time. I'll replace that 5 with a 1. 5 goes into 35 7 times. Replace that 35 with a 7. And then go ahead and take a look at my other two numbers, but I have a 1 and a 2 again. So there's nothing that I can do there to make those numbers simpler. So now I just multiply straight across. 2 times 7 is 14, and 1 times 1 is 1. And that equals 14 over 1, which equals 14. I'm going to skip 3 and 4 because they're quite similar to 1 and 2, and model for you numbers 5 and 6. On number 5, I'm going to be looking at my numbers that are across from each other, diagonal each other, the 5 and the 20. And I see that, again, I know 5 goes into any number that ends in 0. And I know 5 will go into itself, so I'm going to use 5. Using the smallest of the two numbers here is always the better choice if it can be done. It can't always be done, but if you can, it is the best choice, because when you divide 5 by itself, you're going to end up with a number that's as simple as it can get, the number 1. 5 goes into 24 times, so we'll cross that out and put a 4. I'm going to look at my other two numbers that are diagonal each other. And 7, I'm going to look at 7, and I'm hoping that 7 goes into 14, and it does. That's good news, because 7 divided by 7 is 1, and that's as simple as it can get. And 7 goes into 14 2 times. And I now have Much simpler numbers to work with, and I can multiply straight across. 1 times 1 is 1, and 4 times 2 is 8. 1/8 cannot be simplified. We've done our job. We've simplified everything before we multiplied. Therefore, we didn't have to simplify. When we were finished, our product was already simplified. Number 6, I'm going to be looking at my 4 and my 16. And again, I'm looking at 4 to see if I can divide 4 into 16, and you can. So 4 is going to be my best number. I could have started with the number 2, but that would have not been my best number, and I would have been able to do it twice. This way, 4 goes into 4 once. There's no way to simplify 1. 4 goes into 16 4 times. Look at my other two numbers, 2 and 21. And I'm hoping again that 2 will go into 21, but it won't. 21's not an even number, and there's only 2 numbers that go into 2. That's a prime number. And I can't divide by 1. That wouldn't do us any good because we would end up with the same answers. So we're now just going to multiply straight across. 2 times 1, which is 2, and 4 times 21, which is 84. And we can see that this product needs to be simplified. We need to divide this product by 2. And what that means is that we didn't do the entire job when we cross-canceled. There was something that we forgot, something we left out. When I do divide these, I will get 2 goes into 8 4 times, and 2 goes into 4 2 times, so we get 1/42. If we go back to our problem over here, we can see that this fraction here, 2/4, because I had already simplified these two, I'm left with 2/4 here, and 2/4 is not simplified. 2/4 could have been simplified further because 2 goes into 2 one time and into 4 twice. And if I had done that, I would have had 1 times 1, which is 1, and 2 times 21, which is 42. I would have saved myself this step, and I would not have had to simplify. Not only that, it would have made my numbers easier to multiply. 2 times 21 is a lot easier than 4 times 21. I'd like you to pause this video and complete the rest of 1 through 12 that I did not do for you, and then come back to the video for the rest of the lesson. "14, 15, and 16, all word problems. I will model the first one for you, and you will do the other two on your own. In the Fireside Ski Shop, 11/28 of the ski caps have tassels. Of the caps with tassels, 7/11 of them are blue. What fraction of," and I keep seeing that word, "of the caps in the shop are blue with tassels? What fraction of the caps in the shop are blue with tassels?" We're seeing the word of. That means multiply. We're going to take our fractions, and in any order you like, we're going to multiply them. 11/28 times 7/11. I could cross-cancel here if possible. That's one of the things we want to do. I see a lot of large numbers I don't want to multiply. If I were to do that, there would be some large numerators and denominators that I would have to simplify. So rather than do that, we'll cross-cancel. We'll find a number that goes into 7 and 28. That number is hopefully 7, and it is. 7 goes into 7 one time. 7 goes into 28 4 times. Of the 11 and 11 that I have here, well, a number that goes into both of those would be 11. 11 goes into 11 one time, and it goes into 11 one time. It's always nice to see when the numbers are the same. 1 times 1 is 1, and 4 times 1 is 4. There is the appropriate answer. 1/4 of the caps in the shop are blue with tassels. Your job on 15 and 16 are to create the equation and then solve the equation and use the skill you just learned to cross-cancel. Pause the video and complete 15 and 16, then come back to the video to finish up this lesson. I would like you to carry on and complete number 17. Write a response to Puzzle Penguin, who is trying to multiply two fractions and thinks he should get a smaller fraction, but his answer is larger. So tell him what mistake he made. Would also like you to complete numbers 18 and 19, where finally, instead of solving word problems, you get to create them. Have fun, go nuts, use the factors that are given for you and create a word problem. And don't forget to give the solution to your problem. This concludes today's lesson. See you again next time.